Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into part two of how to graph a quadratic function in Vertex form. I'm talking about y equals x minus h quantity squared plus k, or the most general form, actually. Y, let's write this down too. So y is equal to a times x minus h quantity squared plus k, where the vertex v is h comma k. All right, you just have to identify h and k, and you have to know what a, because a affects the shape of the parabola, okay? But h comma k affects the position and where it's going to be located. We're going to be taking a look at where a is not equal to 1. In my first part of the lesson, 7.6a, well, a was either 1 or -1. Here, it's not going to be 1. Here, it's going to be either 2 or 3 or -2, -3, 1/2, or something like that. So let's get right into it. Let's talk about our first parent function here. Given a parabola in vertex form, we want to state the vertex and graph it using only the parent function values. That's our goal. All right. So in this first case right here, we have y equals 2x squared. Notice that a right here, a is equal to 2. Okay, it's not equal to 1 like in my last lesson. So what we need to do is figure out our new parent function values. So I'm going to take a domain, which is a set of x values from -3 to 3. Okay, I'm going to evaluate the function and we're going to learn from it. Okay, this is going to be our parent function. The two examples following here, the offspring, have the same shape as this one because a value is 2. Look right here, and also look right here. So here, a is 2, and here, right here, a is 2. So in both of these, right here, a is 2. So all three of these functions have the same shape. It's just that these second two, examples 2 and 3, have been translated because the vertex is not at the origin. All right. So here we go. This is how you do it. This is how it's done. First of all, you learn the parent values, and then we'll use them. Okay. So when x is -3, we have 2 times -3 squared. Remember, this is 2 times whatever x is squared. All right. 2 times x squared. So you got to square first. So -3 squared is 9 times 2 is 18. All right. So we have 2 times -2 squared. -2 squared is 4 times 2 is 8. And then we have 2 times -1 squared. Always square first, then multiply. All right? Square first, then multiply. All right? So make sure you remember that. Order of operations there. -1 squared is 1 times 2 is 2. Okay? And then 2 times 0 squared, well, 2 times 0 is 0. And then 2 times 1 squared, well, that's 2 times 1 is 2. And then 2 times 2 squared is 2 times 4, or 8. Notice the values are repeating here because of the symmetry of the parabola. And then 2 times 3 squared, well, that's 2 times 9, or 18. So what's happening is this, is that our vertex is right here at 0, 0. And then we're going to go from there, we're going to go right 1, up 2, right 2, up 8. And it was different than our first parent. Our first parent values in the first section here in the previous lesson, y equals x squared. Okay, that didn't happen, okay? So let me just do a little review here. So let me just pick these three values here, 4 values. When x is 0, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. All right, but when you put a equals 2, or when you make a equals 2, instead of going right 1, up 1, as in the first parent, all right, and instead of going right 2, up 4, and right 3, up 9, no, those heights are going to double. Okay, we're going to go right 1, up 2, right 2, up 8, right 3, up 18, because we have to multiply those y values by 2. So you double the height that it goes up. So the problem is going to be more narrow. So let's graph these points right here, 0, 0. All right, right 1, up 2, 1, comma 2, 2, comma 8. So right 2, up 8, 2, 4, 6, 8. And then 3, comma 18. So right 3, up 18, 2, 4, 6, 8, 10, 12, 14, 16, 18, right up here. Okay, and then let's graph the line of symmetry here, right through the vertex. Okay, right down there at the origin. And then go left 1, up 2, left 2, up 8. Basically, it's the same distance on the opposite side. Okay, because of the symmetry. So right 1, up 2, left 1, up 2, right 2, up 8, left 2, up 8. And then from there, you draw your parabola. Okay, it's a smooth U-shaped curve, as I've been saying in all my lessons. Okay, so notice that it's very narrow because a is 2. So this is what 2x squared looks like. This is the parent values. So these values here are what I call the parent values, and is what helps us graph the other two functions. All right, so what we do is we find the vertex, and then from there, because these two have the same shape, we just go right 1 up 2 from the vertex, right 2 up 8 from the vertex, right 3 up 18 from the vertex. Everything is from the vertex. So let's identify the vertex first. So I'm going to write down vertex form, y equals a times x minus h squared plus k. And then you could identify a is 2, a equals 2. So it has the same shape as the parent. That's what this means. And then here, since x minus, look at this, x minus a negative 1 is the same as x plus 1, your h has to be negative 1. Remember, the vertex is always h comma k. So the vertex here is a negative 1, not positive 1, but negative 1, because x minus negative 1 is the same as x plus 1. All right, and then the plus k, well, that's minus 4 or negative 4, so it's going to be negative 1 comma negative 4. So what we do is we plot the vertex first and then use the parent function values. Okay, let's write that down. So we plot vertex first, okay, and then use the parent function values. All right, so you're going to see me do that. I'm going to go left 1, down 4. So I'm going to go left 1, down 4. Let's see here, I'm going to need some more room. So left 1, down 4, and I'm going to write down v, which is negative 1 comma negative 4. All right, there's your vertex, negative 1 comma negative 4. A is positive, so it's going to be opening up. Okay, so this right here is a minimum value. So y minimum, all right, equals negative 4. That's going to help you determine the range. This is a minimum value. Why? Because a is equal to 2, and guess what? It's a positive number. Anytime a is positive, opens up. You should have learned that in our prior lessons. Okay, that's what this tells me right away. It's positive 2, opens up, very narrow. Okay, draw your line of symmetry right through the vertex. Always do that. Draw it as a dotted line. And then what we do is we use the parent values. Once again, they're right up here. From the vertex, we're going to go right 1 up 2 and then right 2 up 8. And we're going to plot and reflect. So right here, let me zoom out just a little bit so you can see the parent values. There we go. All right, we're going to go right 1 up 2 from the vertex. So put your pencil at the vertex and go right 1 up 2 and plot. Okay, right there. Come on. And then reflect. Reflect. It's the same distance, but opposite side. Okay, so we're going to plot and reflect. And then, or you can go left 1 up 2 from the vertex. That's going to do the same thing, right? So we're going to go right 2 up 8. So put your pencil back at the vertex. Go right 2, 1, 2, up 8, 2, 4, 6, 8. It's going to be right here. All right, and then reflect on the other side. It's going to be 2 units away over here. Or you can go left 2 up 8. So you can count from the vertex, go left 2 up 8, and you're going to be at the same position. And then you're going to go right 3 up 18. So right 3, 1, 2, 3 up 18, 2, 4, 6, 8, 10, 12, 14, 16, 18. Excuse me, I didn't count correctly. Let me try it again. Count 3 to the right, 1, 2, 3, 2, 4, 6, 8, 10, 12, 14, 16, 18. There we go. Oh, I did count right. Okay, and now it's 3 units away from the axis, so you go 3 units on the other side. Or you can go left 3 up 18, and then you draw your curve. And it's the same shape as your parent. It's still super narrow because of the coefficient a is 2. That's the same shape. If you actually took a piece of trace paper, which you could do, you could trace the parent and overlap this one. Okay, overlap meaning that they have the same shape. The domain is the set of reals for all these parabolas that are opening up or down. The range, since this is a minimum y value, so minimum y value, oops, come on, let me spell this right. So minimum y value, since it's equal to negative 4, that means all the values on the that are on the parabola, since they lie above it, have to be greater than or equal to negative 4. So y is greater than or equal to negative 4 because this is a minimum, not a maximum. This is like a valley or a low point. Okay, that's what minimum means, okay? And the axis symmetry right here, all right, since it passes through -1 on the x-axis, is x equals -1. X equals -1. It's x equals something. It's always x equals some kind of constant. And just look where it crosses the x-axis, and guess what? It crosses at -1. So the equation of a vertical line through -1 is x equals -1. That's all there is to it. You plot the vertex, and then you use your parent values. Like on this one here, I could see h is 3 and k is -1. So you find your vertex here first. It's always, again, y equals a times x minus h, quantity squared plus k. So you look here, right here, this number here is h, and the other number, this -1, that's k. So it's got 3, -1, so you graph 3, -1, which is right here. 3, right, and down 1. Draw your line of symmetry. And then you simply use your parent values. Go right 1 up 2, right 2 up 8. Okay, so let's do that. So right 1 up 2, and then reflect. Always plot and reflect. Okay, same distance, opposite side. And then you go right 2 up 8. So put your pencil back at the vertex, go right 2 up 8. 1, 2, 3, 4, 5, 6, 7, 8. And then it's 2 units away, so go 2 units on the other side, and then draw your curve. Don't worry about going right 3 up 18 because you're off the grid. Okay, you need at least 5 points to draw a parabola accurately. That's what I tell my students. Continues upward forever, so put the arrows on it. And the domain, let's write down the domain here, is a set of reals. Okay, the range, since this is a minimum value, so y minimum is equal to -1, is y greater than or equal to -1. All these y values above it are greater than or equal to -1. They're bigger. They're above it. If it was going down, I would say less than or equal to that value. Okay, your vertex is at 3, -1. It's a minimum or a low point. Okay, and the axis symmetry here, the vertical line passes through 3 on the x-axis, so it's x equals 3. Now remember, this is a video, right? And so if I go too fast, which I may for some of you guys, really, just remember, pause, play, rewind. Go back into it and listen to it again after you finish taking notes if I'm going too fast. Use the video effectively as you go through the lesson here. So all you need is more experience, okay? A is not always 2. A could be 3 or 4. It could be anything. It could be a fraction too. So let's go through the different variations and get more experience. And after a while, this becomes easy and you get the idea. Okay, now here, A is equal to 3. So let's write that down. So this right here, this is your A value. It's equal to 3. So y equals 3 times whatever x is squared. So let's get your parent values first. It's going to be 3 times the original parent. 3 times as high, so it's going to be even more narrow. So let's take some values in the domain. Let's take 3 times -2 squared. That's 3 times 4, or 12. And then we're going to take 3 times -1 squared. 3 times 1 is 3. 3 times 0 squared. That's 3 times 0 is 0. And 3 times 1 squared is 3, obviously. And then 3 times 2 squared, 3 times 4, 12 again. So my parent values are simple. We have the vertex right here. And then we're going to go right 1 up 3. Instead of right 1 up 1, we're going to go right 1 up 3 because it's 3 times as high. Instead of going right 2 up 4, like on x squared, we're going to go up 3 times as high. So we're going to go up 12, okay? Okay, so let's plot. So we have the origin down here, and we're going to go right 1 up 3. And then reflect, left 1 up 3, right over here. And then we're going to go right 2 up 12, 2, 4, 6, 8, 10, 12. And then go left 2 up 12 over here, and we're going to draw a curve. And it's very narrow because A is 3. This makes it narrow right here. Makes the parabola narrow. Okay, not wide. If it was a fraction, it would be wide. All right, but when A is a value bigger than 1, the parabola gets more narrow. So this is what 3x squared looks like. Let's say it's more narrow than 2x squared, more narrow than x squared, okay? Now notice here on all of these, the offspring right here, guess what? A is 3. All right, so these are going to have the same shape, but shifted. All right, same shape, all right, but shifted. The vertex is not at the origin, okay, like it is in the parent function. So these parent values are the ones we're going to use. And we're going to use them to graph the offspring, okay, which look just like this, but just been shifted because the vertex is in a different position. So let's identify the vertex first. So let's write down vertex form underneath it and compare. And you'll see that the vertex is 1, -4. Okay? And so we're going to graph the vertex, then use these parent values. So here, whoops. Okay, right about, there we go. All right. Oh, nope. Okay, so we're gonna have to, I'll just have to scroll up and down. That's all I have to do. Okay, so let's plot 1, -4. So 1, -4 is right 1 down 4. It's right here. 1, -4. Let me just verify that. Okay. All right, draw your line of symmetry. No, 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 no. Okay, always draw the line of symmetry first, or what's called the axis symmetry. And we're going to use it. So they're parent values this time for 3x squared. Okay, instead of going right 1 up 1, we're going to go right 1 up 3 because it's 3 times as high. So right 1 up 3. So put your pencil at the vertex, go right 1 up 3. 1, 2, 3, and plot a point. And then go left 1 up 3, and you're over here. Notice the symmetry. Okay, instead of going right 2 up 4, we're going to go right 2 up 12, 3 times as high. So here we go, right 2 over here, up 2, 4, 6, 8, 10, 12. Reflect over here, or you can just go left. Oh, not over there. That was in the wrong position. When we go left 2, which is right here, and then up 12. 2, 4, 6, 8, 10, 12. Right there. There we go. There's the symmetry. So reflect over here, reflect here. Let's draw the curve. Same shape as before on the parent. All right, it continues upward forever there. All right, but it's been shifted right 1 down 4. The domain is the same, all reals. This is a minimum value, so your y minimum is equal to -4. That's the lowest point right there. So the range has got to be greater than or equal to -4. Axis symmetry is right here, and it runs through 1 on the x-axis, so x equals 1. As I said before, it's a minimum at 1, -4. Okay, let's get some more experience here. So at this point, you could pause the video maybe and try it, right? Pause and play. You pause the video here, give it a shot, and then press play, and let's see if you get it right. Use the video to your advantage, all right? All right, so A is 3. So A equals 3. All right, it goes up. That's an A. All right, x minus a -6 is the same thing as x plus 6. So there's H and there's K. So -6, comma, +1. There's your vertex. So left 6 up 1. So left 6 up 1 is right here. So 1 comma, excuse me, -6 comma, -6 comma 1. Okay, yeah, that's correct. And now from there I go right 1 up 3. So right 1 up 3 would be here. Let's draw that line of symmetry here. Okay, and then reflect it, or go left 1 up 3, and then use your parent values, right? Go right 2 up 12. So let's go right 2 from here, up 12. 2, 4, 6, 8, 10, 12. And then reflect it over here. So now draw your parabola. No. Smooth U-shaped curve. Okay, domain all reals. Range, okay, here's your minimum y value. So your y minimum is equal to 1. Okay, so that means y has to be greater than, the range is always y values, as opposed to the domain is the set of x values. It's got to be greater than or equal to 1. Yeah? The axis symmetry is right here, passes through -6, so it's x equals -6, because it goes through -6 on the x-axis. Vertex, as I said before, is -6, 1, and it's a low point or a min. Okay, minimums are low points. All right, now the a value may be negative, in which case it opens down. So on these right here, when a is equal to -2, okay, that tells me that the parabola opens down. From experience in my former lessons, you know that. So parabola opens down because a is negative. Okay, because a is negative. Come on, let me write a little bit better here. Negative. There you go. Now, when it's positive, opens up. If it negative, it opens down. Okay, so these are going to have maximums. All right, so let's learn about the parent here. Now, you could use the same parent values as the first example because a was 2. But it's going to open down, so all the range values are going to be negative. So instead of going right one up to, you're going to go right one down to because a is negative. Okay, you could do that, but I'm going to generate the parent values again so you can see them. So I'm going to take it from -3 to +3 in the domain, just so I have a lot of parent values. All right, and it's going to be equal to -2 times whatever x squared is. So -2 times -3 squared. Square the -3 to get 9, times -2 is -18. Notice that's why we go down as opposed to up. And then you're going to have -2 times -2 squared. Oops. That's -2 times 4, or -8. Notice the range is all negative. -2 times -1 squared is -2 times 1, or -2. So we're going to go left and down, left and down. Okay, that's why the parabola opens up downward. Okay, downward. So -2 times 0 squared, obviously 0. -2 times 1 squared is -2. -2 times 2 squared is -2 times 4, -8. And -2 times 3 squared, -2 times 9, or -18. So in this case, our parent values, there's your vertex right here. We're going to go right 1 down 2, right 2 down 8, right 3 down 18. Okay, these are the new parent values. And because of this, the parabola opens up downward. Okay, so here's your x-axis up here. Here's your y-axis. Here's your vertex right here at 0, 0. We're going to go right 1 down 2. And then reflect. Go left 1 down 2. Left 1 down 2. And then right 2 down 8. Right 2 down 8. 1, 2, 3, 4, 5, 6, 7, 8. And then go on the other side. And then right 3 down 18. Okay, right 3 down 18 is way down here. Oh no, it's off the grid, so I'm not going to worry about that one. Okay, I'm just going to go ahead and graph it. Okay, smooth U-shaped curve. Okay, so A makes it negative. A, since A here, right here, is -2, the parabola opens down. Okay, that's what happens when A is negative. So all of these functions here, this one and this one, right here, these have the same shape. It's just been shifted. So these are going to have the same shape, but different vertex. Let me write that down, okay? These have the same offspring, which are the next two examples here, offspring. Same shape, but shifted. Shape is, come on, Ainsworth. Let me say same shape. Same shape, all right, different vertex. So all you have to do is find the vertex and then use these parent values. Go right 1 down to 2, right 2 down 8, and then plot. It's that simple. All right, so we're going to identify the vertex first. So here we go. Vertex form, y equals a times x minus h squared plus k. Always write that down below and compare. I can see that h is 1. I can see that k is 4. All right, so 1, 4 is my vertex. All right, and again, it has the same a value right here, a equals -2. So we're going to plot 1, -4, which is right 1 down 4 right here. And then we're going to graph the parabola. Okay. So let's see here. Whoa, why did I say negative? Positive. So let me regraph this, okay? Right one up 4, sorry, going too fast. So it's up here. So 1 comma up 4, guys. I'm sorry, k is positive right here. My bad, but I fixed my mistake. Okay, so we're going to draw the axis symmetry. No. Okay, I always do that first. Helps you reflect, okay? Always plot and reflect. Okay, and here we go. We're going to use those parent values. So instead of going right 1 down 1, we're going to go right 1 down 2. So right 1 down 2 is right here from the vertex. Left 1 down 2 is right here. Just count. And then we're going to go right 2 down 8. So right 2, 1, 2, down 8. 1, 2, 3, 4, 5, 6, 7, 8 right here. And then reflect over here. Okay, or you can go left 2 down 8. Same thing. Okay, and then draw your curve and you're done. Done graphing, that is. Okay. All right, and now let's state the domain and range. So now these are high points, okay? So check this out. This is a max. So y max is equal to 4. That means all these y values on the curve have to be less than or equal to it because they're below. Ooh, yeah. Okay, so because of that, we have all reals here for the domain. The symbol for that is this right here, capital R. Range y less than or equal to 4. Axis is symmetry right here, goes through 1 on the x-axis, so it's x equals 1. And then its vertex is 1, 8, 1, 4, 1, comma 4. It's a maximum. It's a high point. Okay. Okay, and that's how it's played, guys. That's how it's done. The only thing you have to do is get good. Okay, so pause and play a little bit here. You try the next one. Pause the video, give it a shot, and press play when you're ready. Okay, I'm going to assume that you did it. So here we go. So a times x minus h, quantity squared plus k. Since x minus a -3 is the same as x plus 3, here's h. H is -3. So it's -3 comma 8. So you're going to go left 3 up 8. So we're going to go left 3 up 8. Plot, draw the line of symmetry right here. So -3 comma 8. A is 2, so this is a max. Here's your max y value. You can already see it. Max y value equals 8. So it's going to go below that. So here we go. We're going to go right 1 down 2, left 1 down 2, right 2 down 8, and the left 2 down 8. So we're going to graph it from here. And we're going to state the domain and range. Okay, the domain for all the parabolas that are open up or down, not sideways, but open up or down, all right, is a set of reals. The range depends on the vertex. So because of this, I can tell that the range is less than or equal to 8, all right? The range always depends on the vertex. And then the axis symmetry right here, it's a vertical line passing through -3. So it's x equals -3. And the vertex, as I said, is -3 comma 8. It's a high point or a max. All right, and hopefully you're getting the idea because they're all done this way, guys. They're all done this way. All right, so this one here is very similar. This one's -3x squared, so this one opens down, okay, because a is negative. So right here, a equals -3, parabola opens down, and so let's get some values here. So we could use the values for 3x squared, which is, where is it? Let's find it. Okay, right here. So we could use these values here, but instead of going right 1 up 3, we're going to go right 1 down 3. Instead of going right 2 up 12, we're going to go down 12 because of the negative. Okay, so you could learn from the past. All right, but I'm going to generate the values again, okay, just because I'm trying to teach you guys something here. So hopefully the light bulb is going on and you're starting to understand this stuff. So we're going to take negative 3 times whatever x is squared. So negative 3 times negative 2 squared is negative 3 times 4, or negative 12. Negative 3 times negative 1 squared is equal to negative 3 times 1, or negative 3. Negative 3 times 0 squared is 0. Negative 3 times 1 squared is negative 3. Negative 3 times 2 squared is negative 12. So these parent values, we're going to go right 1, down 3. Right 2, down 12, because a is negative. It makes the parabola open down. Okay, parabola opens downward. Whenever the a value is negative, or the lead, what's called the lead coefficient, it opens down. So these are the new parent values. We're going to go down instead of up. Okay, so let's plot the vertex here, and then go right 1 down 3, very narrow, left 1 down 3, and then we're going to go right 2 down 12, and then left 2 down 12. We're going to graph this parabola, very narrow, steep, all right, opening down. Okay, this is what negative 3x squared looks like as a function. Now these right here, all right, these functions here have the same a value. Look at that, they're all negative 3, which means they have the same shape but shifted. So the offspring have the same shape, all right, but shifted, all right. Why? Because it has a different vertex. It's not at the origin. Here's your vertex right here. Let's call that V for vertex at 0, 0. These don't. These vertices here are different. So what we do is we plot the vertex and then use your parent values. So here we go. So we have a times x minus h, quantity squared, plus k. Notice how I write down vertex form every single time. I can see that h is 1, and I can see that k equals 8. So I can see that is 1, 8 as a vertex, and it has the same a value. A is equal to negative 3. So it has the same shape. It's just been, the vertex has been shifted from the origin to 1, 8, and it opens down. So we got to plot 1, 8 first, which is right here. Okay, draw the line of symmetry. Always draw the line of symmetry as a vertical line. Okay, that's x equals 1. And then use your parent values. Here we go. So we're going to go right 1 down 3 from the vertex. So put your pencil at the vertex, go right 1 down 3, go left 1 down 3, or you can reflect it. And then second parent value is right 2 down 12. Okay, if you have room on the plane, which I think we do. So go right 1, 2, down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, it's 2 units away. Go 2 units on the other side. So once again, I reflected, plot and reflect. Plot and reflect. And so then after that, you just draw your curve, right? Put sound effects in. All right. Domain, all reals, range, since this is a max, this is y max. All right, it's equal to 8. All right, that tells me that all the y values are less than or equal to 8 because they lie below it. All right, all the y values on the parabola are below the vertex, so they have to be less than or equal to that value. Your vertex is at 1, 8. It's a max, it's a high point. All right, the axis symmetry goes through 1 on the x-axis, so it's x equals 1. All right, now it's your turn. Okay, so on number 12 here, you determine the vertex and you try it, and when you're ready, press play. All right, I'm going to assume you did it, so here we go. So a times x minus h, quantity squared, plus k. Okay, there's your vertex form. So I can see that since x minus a negative 3 is the same thing as x plus 3, I can see that my h value is 3, k is pretty obvious, it's 12. So it's 3, 12. And a is negative 3 again, like I said right here, so it opens down. and it has the same shape as the parent. So let's go, I'm sorry, x is negative 3. So negative 3 comma 12. So we're going to go left 3 up 12. Slow down, Ainsworth. So left 3 up 12. Okay, so negative 3 comma 12. Draw your line of symmetry. All right, and now use your parent values. We're going to go right 1, down 3. So put your pencil at the vertex, go right 1, down 3. Back of the vertex, left 1, down 3. And then we're going to go right 2, down 12. So right 2, down 12. And then left 2, down 12. And then draw your parabola. No. Okay, that continues downward forever. Smooth U-shaped curve. Smooth U-shaped curve. All right, we can see all sorts of things. I can see x-intercepts here. I can see this is the y max. So y max is 12. That's a max. Let me spell correctly. So that means that all the y values in the range have to be less than or equal to 12. So all reals for the domain, range, y is less than or equal to 12. Vertex, where was it again? Negative 3, 12. Negative 3 comma 12. It's a max. It's the high point. Axis symmetry is right here. It passes through negative 3. So it's x equals negative 3. Okay, because guess what? It goes through negative 3 on the x-axis. Okay, as I keep on repeating. So hopefully after all this repetition, you're starting to get this. Hopefully that you can do this one on your own. So pick a domain from, let's say, negative 2 to 2, and then get your parent values here. Now notice here, a is 1/2. Okay, a equals 1/2. So it opens up, all right? However, you only go up half as high. Okay, so here we go. So it's going to be 1/2 times negative 2 squared. You always square first. So it's going to be 1/2 times 4. Well, half of 4 is 2, right? So divide. 4 divided by 2 is 2. So you get 2 here. Half of 1/2 times 4 is the same thing as 4 divided by 2, or 2. Half of 4 is 2. And then you take 1/2 times negative 1 squared, which is a half times 1, which hopefully you see as a half. And then 1/2 times 0 squared, which is 1/2 times 0 is 0. There's your vertex. And then 1/2 times 1 squared, which is a half times 1, or 1/2. And then 1/2 times 2 squared, which is the same as above up here. It's a half of 4. What's a half of 4? Well, it's 2. Right? 4 divided by 2 is usually 2. So your parent values, you're going to go right 1, up a half. Right 2, up 2. So it's a little bit different here. See, on our parent function, our original parent function, x squared, I'm just going to do this real quick here. We have 0, 1, and 2. X, 0 squared 0, 1 squared is 1, 2 squared is 4. On the original parent, we want right 1, up 1. We want right 2, up 4. But because the a is 1/2, we go up half as high. So instead of going right 1, up 1, I go right 1, up a half. Instead of going right 2, up 4, I go right 2, up a half of 4, which is 2. I go up half as high. All right, so let's graph this. So your vertex is here. Go right 1, up a half, which is right here, and then right 2, up 2, which is here, and then go left 1, up a half, and then left 2, up 2, and then you go ahead and graph from there. So it's not narrow, no. When you have a as a fraction here, there we go. All right, it's more shallow, or it opens up wider. So this makes it wider. Okay, makes it wider. So this is 1/2 x squared. Now these are the parent values. Parent values, and these are the ones we're going to use down here, because these offspring have the same a value. Okay, they're all equal to either 1/2 or negative 1/2. So either you go right 1, up a half, or you go right 1, down a half. You go right 2, up 2, or you go right 2, down 2, depending on whether it's positive or negative. That's all you do. And hopefully you guys are starting to realize that. So let's find the vertex first. I can see h here and k here. So 1 comma negative 4 is my vertex. Here, a is 1/2. So let's plot the vertex first. So 1, negative 4. Draw your line of symmetry. There we go. All right, and now let's go back to the parent values. I'm going to go right 1 up 1/2 and right 2 up 2. Here we go. Put your pencil to the vertex. Go right 1 up 1/2, left 1 up 1/2, right 2 up 2, left 2 up 2. All right, same shape but different vertex. Let's do this another one here. But this case, a is negative 1/2. So a equals negative 1/2. Okay, opens down. Okay, because of this negative. Opens down. Let me spell it better. There you go. So it looks like this. All right. So let me see. X minus a negative 3 is the same as x plus 3. So h is negative 3. Here's k right here. So we have negative 3 comma 1, it looks like. Here's my vertex. So left 3 up 1. So negative 3 comma 1. Draw your line of symmetry. And then you go ahead and graph, okay? So, but this case, we're going to go down. So my parent values are 1, right 1, down 1/2, right 2, down 2. So we're going to go down 1/2 a unit. So right 1, down 1/2 a unit, left 1, down 1/2 a unit. Right 2, down 2, left 2, down 2. So notice this parabola opens down, no, like this. All right, because guess what? A is negative. So this is y equals negative 1/2 x, excuse me. I didn't mean to say that. That was the parent function. So this right here opens down because of the negative. That's all I meant to say. All right, when a is positive, it opens up. When a is negative, it opens down. And that's a lot of the discoveries that we made throughout the unit here. You guys are using all those skills in this right here. Okay, I think that's it. And so remember, this is a video, right? So if you need to rewind, okay, you may. All right, and you could see how it's done. So we use our parent values and to help us out graph the new ones. And by the way, let me just show you something real quick here. When it comes to parent values, you might want to do this. I'll show you a little cool little study tool. All right, so if we're making a table here, let me just make a quick table. Whoops, sorry about that. Okay, so make a quick table here. Come on, Ainsworth. All right, here's the X. Just make a little table. Watch, this can really help you out. So this is the parent values. Let's call this parent values. This will help you when you do take your test here. So X here, and 0, 1, 2, 3. Okay, now when you square x, if the function was x squared, the parent function right here, 0 squared is 0, 1 squared is 1, 2 squared is 4, and then 3 squared is 9. That's your x squared. If you see the parent function y equals x squared where a equals 1, this is when a equals 1, then you use these parent values. When a equals 2, you have 2 times x squared. You just double all these. So 2 times 0 is 0, 2 times 1 is 2, 2 times 4 is 8, 2 times 9 is 18. When a equals 3, you have 3 times x squared. So you got to multiply these x squared values by 3. So 0 times 3 is 0. 1 times 3 is 3. 4 times 3 is 12. 9 times 3 is 27. And then when, let's say a is equal to 1/2, you have 1/2, let's say x squared. You got to multiply all these x squared values by 1/2. So 0 times 1/2 is 0. 1 times 1/2 is 1/2. 4 times 1/2 is 2, or half of 4 is 2, and half of 9 is, well, it's 4.5, right, or 4.5. Okay, and if you want to make one negative, you can. So if you want to go negative 2x squared, if you want to develop the table for that, when a equals negative 2, then you take these x squared values here and you multiply by -2. So 0 times -2 is 0, 1 times -2 is -2, 4 times -2 is -8, and 9 times -2 is -18. So it all relies upon your parent values. So you're going to go right 1 and then you're going to either go up 1, right 2, up 4, right 3, up 9 if it's x squared, or if a is anything other than 1, well, you use your other parent values. So knowing this right here, or using this on your, let's say a test or homework when it varies and they're all different, might help you quite a bit. All right, and remember, you can always go back to my lesson, which is right through here, and you can go for it and listen to it again if you need to. So use the videos on my website to your advantage. This is Mr. Ainsworth. I am done at this point, and I'll see you in my next lesson. Make yourself proud, work hard, study well, finish your homework, and I'll see you later. Bye-bye.